So when reading this question, the first word that should really stand out to you is extrema. That's what we need to find. And we said that to find extrema, we take our derivative, set it equal to 0 or does not exist, and then we draw a number line and plug into the derivative. So to find our derivative here, the first thing that we'll notice is that we have parentheses to a number. So that is the structure of the general power rule. So our first step is that we will bring down the 1/3, keep the inside fixed, subtract 1, so 1/3 minus 1, again that minus 1 is really a 3/3, we get negative 2/3 as the new exponent. And then the third step of the general power rule is that we have to multiply by the derivative of the inside. But when we take the derivative of x, we just get 1. The derivative of 1 is 0. So there's an understood 1 here that we do not need to write. Now, what we need to do is we need to set this equal to 0 or does not exist. And the easiest way to do that is to remember that your goal in this process of setting it equal to 0 or does not exist is to get one fraction. And basically, anytime you have negative exponents, you don't really know how to deal with those. So you always want to remove the negative exponents, because that way it will be a little easier for us to figure out where the derivative is equal to 0 or does not exist. So when I see this negative exponent, I'm not going to keep that in my life. I am going to move that negative exponent down into the denominator so that it will then become a positive exponent. Now, once I do that, I can then achieve this setting it equal to 0 or does not exist by setting the numerator equal to 0 and setting the denominator equal to 0. So if I set the numerator equal to 0, I just have 1 is equal to 0. There's nothing to solve for there. If I set the denominator equal to 0, there is a variable x to solve for. And we talked about this in class, but remember, we can divide by 3. 0 is going to still be 0 when I divide by 3, and I can raise this to the 3/2 power. 0 to the 3/2 power is still going to be 0. So really it's about setting this parentheses, this factor part, equal to 0. So we want x plus 1 equal to 0, the parentheses quantity, and so that gives us x is equal to -1. This is our critical number, and with that critical number we then draw our number line. Now, there is one observation that is really helpful to make here. If you look at your derivative as it is written before you set everything equal to 0 is 1/3 times x plus 1 to the 2/3 power. This is the same thing as 1/3 x plus 1 to the 2nd power, and then raising that to the 1/3 is the cube root. But what really should stand out to you here is that you have a quantity squared when you have that 2 even exponent. And whenever you have something squared, it doesn't matter if it's a positive or a negative, that squared expression will always be positive. So if you look at the derivative, it doesn't matter what number I plug into the left and what number I plug into the right. And again, you can always check by plugging in numbers, but the reality is the 1 is going to be positive, and then because of this 2 here, this even exponent tells us that we're not going to have a sign change. And specifically, it is the even numerator exponent that we need, because the numerator exponent would correspond to a power inside of the radical. So this is going to be a positive. And again, you can verify this. If you plug in -3, you are going to get a positive. If you plug in, let's say 0, you are going to get a positive. So what that tells us is that we are going up, and then we continue to increase. And so for that reason,